Hello, science teachers. Welcome to Science Teacher Summer School, Episode 4. I'm Kent Louie, and something you may not know about me is that I can solve the Rubik's Cube in roughly 2 minutes. It took me about 3 months to practice the algorithms needed to do it, but I think now getting my time below 1 minute is really going to be a challenge. Now, let's get to work. Science videos. What science videos do you show in class? I mean, we all show them. And with YouTube, there's a lot out there. Professionally made videos by companies like National Geographic or Wired Magazine. There are videos by so-called science communicators like Smart Everyday, Veritasium, and Physics Girl. And there are videos by teachers like Boastman Science, Amoeba Sisters, and Khan Academy. Now, this past year, I became more aware and selective of the videos I was showing in class because instructional time inside the classroom became more precious due to pandemic restrictions. No longer did I want to just show videos that just repeated what I just mentioned in class or was just entertaining or funny. I wondered if my videos and their complementary activities were a good use of time and really furthered student learning. So I asked, what activities and videos would really help my students become better science thinkers and science doers? What I try to do in my class is first, I try to provide ways that allow students to process and connect with the video. And two, then I show the right type of video. Now, let's start with a couple of strategies that allow students to connect with the videos. I provide a couple of open-ended ways. The first way comes from my days of being a teacher on call, subbing for a Vancouver teacher. Shout out to Christopher Rositis for showing me this in his teacher on call notes. I have students draw a T-chart and on a sheet of paper, and they write what I know and what I learned on both sides of the T-chart. I ask students to take notes while they're watching the video. They can take notes on anything that is mentioned in the video on either side of the chart. I'll ask students to write 10 points or 12 points or 15 points, depending on how long the video is. And these are cumulative points, meaning they can write 5 on one side, 5 on the other side, or 7 on one side, 3 on one side. However many it takes to reach the total. After the video, I'll collect the notes and mark them. A second strategy I give my students to connect with and process a science video is a set of 3 questions. First, what I just saw makes me think about this other thing I learned in another class because, number 2, what I just saw makes me think about the time because, and number 3, what I just saw makes me think about the future because. Now, after a video, I'll provide 5 to 10 minutes for students to write responses to these questions. For example, what I just saw reminds me of this thing I learned in English class because. Then we go around the classroom and we discuss. The discussion is actually what's important. Now, both these strategies I use with almost all my videos. They're easy, they can be personalized, and they work great in getting kids to connect. Now let's take a moment to talk about the type of science videos to show in class. I like to show more issue-driven science videos and fewer videos that are content or phenomenon-driven. Content-driven videos are explainer videos, like the ones produced by Khan Academy. They contain a lot of information, but I don't like to show them too often in class because it goes over too many concepts I already go over in class. However, if there's something a video shows that I can't show in class, then of course, I'll show a content video. Phenomenon-driven videos are cool demos and builds that people show on YouTube, like the ones done by Mark Rober and Veritasium. These are cool to watch, and a lot of kids are hooked to these videos. They're great for getting students interested in science and engineering, but I don't show them too often in class because they often don't connect with the content I'm teaching. Plus, my perspective on videos have changed. When I first started, I wanted to show how science was cool with explosions and stuff. Now I want to show science serving a larger purpose and solving larger problems. Issue-driven videos highlight how science is used to solve a global issue. For example, Business Insider has a great miniseries called Worldwide Waste, where they highlight interesting solutions to our waste problems, like using microbes to extract metals from computer chips, and using coffins made of mushrooms to make our burials more environmentally friendly. These videos take content and apply it to real issues, and that's what I want to highlight in science. That's all the time we have for this episode. Please write your questions in the comment section below. Join me next time when I'll be talking about how I run engineering inquiry projects so that my students actually learn by doing. You don't want to miss it. See you again soon, and remember, to science everywhere, every day.